So, angle relationships in quadrilaterals. Adjacent means next to or adjoining. Supplementary means adding to 180 degrees. Transversal means a line that intersects two or more lines. And finally, congruent means equal in all respects. So equal angles and equal sides. Same shape, same size would imply congruent. Now, looking at all these four words, let's look at these words and how they will affect in terms of a graph. Adjacent, so the best way to understand what adjacent means is by looking at a right angle triangle. A right angle triangle has a little square in the corner where the 90 degrees is. This 90 degrees means that opposite this angle is the hypotenuse. So the right angle points to the hypotenuse. So this side would be known as the hypotenuse because that's where the right angle points to it. If I was to change that, I could change the hypotenuse by changing what my triangle looks like. So I'm going to erase this hypotenuse and we're going to change the triangle. Changing the triangle to turn sideways like this means now that the right angle points over here, this side will be my hypotenuse. The hypotenuse is always the longest side of a right angle. The hypotenuse is also always the longest name as well. Now, how does that affect us? Well, in a right angle triangle, we know where the hypotenuse is, and we have two other angles in the triangle. This angle, for example, we can call that angle theta. Theta is a Greek letter used to represent an angle. Sometimes we use a variable, but oftentimes in math we use a Greek letter to represent the angle. Now notice that this angle touches two sides. One side is the hypotenuse. The other side is next to the hypotenuse. What side means next to? That's right, the adjacent side. So the adjacent side is a side that touches an angle, and that angle in a right angle triangle always touches a hypotenuse and an adjacent side. So that's what they mean by adjacent. Supplementary means that if you have 180 degrees and a 180 degree line as such right here, and I add A, B, C, and D, I add up all of those, A plus B plus C plus D, that will equal a total of 180 degrees. So adding up all of these angles will equal 180 degrees. What does transversal mean? Well, transversal means you have two random lines. They don't necessarily have to be parallel, but in the case we're going to be looking at today, there will be more likely parallel. Okay? We have two lines and a line intersecting those two lines. So that's known, this line right here is known as the transversal. The last one, congruent. Congruent means same shape, same size. So if I was to take a triangle and draw a triangle, as such, we're going to draw one here. If I take a triangle, or a circle, not a circle, a triangle, and we draw this triangle out, I can take this triangle and make a complete duplicate of that triangle, and these two triangles would be considered congruent because not only are they equal in all sides, such as this, all the sides are equal, but also all of their angles will also be equal to each other. So that's what congruent means. Okay, moving on to our chart. Today we're going to add to that chart that we had earlier in the previous lesson, and we're going to add some more theorems. So I'm just going to go over all of the theorems yet again. Supplementary angle theorem, in short, is known as SAT. That means A plus B is equal to 180 degrees. Complementary angle theorem is known as CAT. CAT is the breakup of a 90-degree triangle, 90-degree angle, which adds up the two angles that break up the 90 will add up to 90 degrees. So again, supplementary angle, the breakup of a straight line into two or more individual lines. Complementary angle theorem is the breakup of a 90-degree angle. Next, we had sum of the angles in a triangle theorem, SATT, which stands for sum of the angles in a triangle, which add up. A plus B plus C equals 180 degrees. Next, we have isosceles triangle theorem, which was a triangle, ITT, with two sides that are equal, and those two sides equal means that two angles are equal in ITT. We also had equilateral triangle theorem, which is short for ETT, which stands for basically all the angles, all the sides in an equilateral triangle are equal. Therefore, all the angles in an equilateral triangle are also equal. So 60 plus 60 plus 60 equals 180. So all the sides are equal. That means all the angles are equal. Equilateral triangle, the triangle is equiangular. Next, we have an exterior angle triangle theorem. An exterior angle triangle theorem is EATT. And that is, if I create an exterior angle along one side of the triangle, that will equal the sum of the other angles that are opposite of its supplementary angle. So A plus B will equal the value of C. That's known as EATT. We also had opposite angle theorem. Opposite angle theorem implies OAT for short, implies that we have two lines that intersect, and those intersecting lines have unique angle properties. That is, that this A is also equal to this A. Those two angles are equal, and therefore these two angles are also equal because those angles are opposite. So that is known as the opposite angle theorem. Next, we have quadrilateral angle interior angle theorem, also as QIAT. QIAT states that in a quadrilateral, that is a four-sided shape, we can add up all the angles, A plus B plus C plus D, and they will equal 360 degrees. Next, we have the quadrilateral exterior angle theorem, and that states that the exterior angles of a quadrilateral, so the supplementary angles to the interior angles, will also equal 360 degrees. So W, X, Y, and Z will add up to 360 degrees. Next, we have parallel line theorem. Parallel line theorem. These are new now compared to your chart, so we're adding to our chart. We have three parallel line theorems. First one is corresponding angle. Corresponding angle you would remember it as the F pattern. PLTF. PLTF states that you have your two parallel lines with the transversal. Your parallel line theorem would be so that this angle is equal to this angle. That is, you should see an F pattern right here with those corresponding angles. Another place that you could see it, if we follow through, is another corresponding angles here and here. That is, our F pattern is upside down and backwards over here. And if you don't see this F pattern, we have another F pattern, and that is when this angle is equal to this angle, and my F pattern happens here. So there are multiple F patterns found with the transversal and parallel lines. So an F pattern can occur right here, coming down, and the arms of the F are along these parallel lines. That is an upside down F. We have an upside down backwards F if we look backwards over here. We have a backwards F over here, and we have a forwards F down on the bottom here. So the idea is that the corresponding angles are always equal. So there's our F pattern, and we can have multiple F patterns, folks. There's another one right there. Now, parallel line theorem. Alternating angles means that we're looking for a Z pattern, that is PLTZ. Or PLTZ means that we have parallel lines, and then we have a transversal, and with that transversal we can create a Z like such, which implies that this angle is equal to this angle. Now that's not the only z, folks, because we could have another z in yellow here going in this direction. And we can see that this angle right here will equal this angle. So that is a z backwards. And that those angles will equal each other. Now the final parallel line theorem is the C pattern. Parallel line theorem, co-interior angles. Co-interior angles is a C pattern, also known as PLTC. How do we get that? Well, we have two parallel lines and the transversal. And what happens here is we create a C as such, and this angle inside here, the interior angle here, plus the interior angle here, will equal 180 degrees. That is, x plus y will equal 180 degrees. Okay, folks, so we've just added 3 more theorems, and we'll be adding more a little bit later. The last one that we're going to add in the next lesson is going to be the polygon angle theorem. So we're just going to add this last theorem into our chart now. And that is the polygon angle theorem, which is PAT for short. PAT stands for the fact that we can determine the sum of any of the angles of any polygon from triangles all the way up to n particular sides. The sum of the angles in a polygon is always equal to the following formula: 180 times n minus 2. And we'll be looking at this example in the next lesson. Moving on. Example 1. Solve for the following indicated angles. It could be one or more angles. So we have a polygon with a transversal with a bunch of missing information. We have another one, the parallelogram, and we're going to determine these values here. So let's look at what the values are. Here we go. First one. I know that this is 35 degrees, this one is 45 degrees, and we have angle x and angle y, which we need to determine. Well, looking at this, I have some parallel lines happening here. These two lines over here are parallel, and these two lines over here are parallel. I know that this 45 is equal to something else in this triangle. What is it equal to? That's right, it's equal to y. Y is equal to 45 degrees. Now, you can't just state 45 degrees, you need to state y. Y is equal to 45 degrees because of PLT Z. That is, if we look here carefully, if I go across here, come down, and go across here, that creates our Z pattern. So let's do that in a color so you can see that. So you can see the Z pattern. The 45 is going to equal the Y value. Next, we need to figure out what X is. Well, now I know what this is. So I have 35 here, I have 45 here, I can determine X. How do we determine X? Well, X is equal to 180 minus the sum of 35 plus Y. Y was 45. So X is equal to the sum equal to 180 minus the sum of 35 plus 45. And that will give us a total of 80. So 180 minus 80 will equal 80 degrees. Now look at the way I solved this. I used PLTC to solve for this value. That will equal 100 degrees. X is equal to 100 degrees. Is that the only way we can solve it? Well, no, we could have used SATT to also solve for X, and that is the sum of the angle in a triangle theorem. So whether we use C pattern, which we did here, or SATT to solve for X, you will get the full marks because you provided reasoning. Next, this next problem, we need to look at this. We need to solve for X, Y, and Z. X, Y, and Z over here. So how are we going to do that? Well, I can determine the value of Y right away. I can also determine the value of X, and then we have to determine the value of Z. So let's go. y is equal to 75 degrees because of PLTZ. You should see the Z pattern happening from here, down, and across. So Z pattern is found with y and 75. They are alternating angles. X is equal to 180 minus 75 because of SAT. That is, x is equal to 105 degrees. Next, we need to figure out Z. A lot of you have already figured out that Z is probably equal to 105 degrees. But how do we get that? Well, we know that y is 75. We need to determine Z, and we can use PLT-C for our answer here. Or we could have determined the value over here, which the value over here would be 75 degrees because of PLT-F. Lying on its back over here, you can see an F. Let me draw the F out for you so that you can see that there is an F right here going across and up over here. So there's an F pattern there, and we can do that, determine the F pattern with that, and then we can determine Z using C pattern, or we could determine Z using the quadrilateral interior angle theorem, QIAT. Either way, folks, the whole idea is you justify your reasoning and you'll get the full marks. All right, moving on. We have an example here, and we need to determine the value over here. And that is, we need to determine the value of y, z, and x, which is up here. And these do not mean that y and these x and z are not equal, folks. They're different values. So how do we determine the values? Well, y we can determine to be 120 because of PLT-F. We can also determine that y is equal to 40 degrees because of PLT-F as well. So x is equal to PLT-F, y is equal to PLT-F. Those are the reasoning, and the answers are 40 for x and 120 for y because of PLT-F. And you can determine z is equal to 80, and the reason you can determine that is using exterior angle theorem. Okay, one more time. Z is equal to the sum of the exterior angles. So z plus 40, right here, z plus 40 is going to equal 120. 120 is our exterior angle. Z plus 40 is equal to 120. That means z is equal to 80 degrees because of EATT. Another way you can prove that z is equal to 80 degrees, that is by taking z is equal to 180 minus 40, and we need to determine the value of w, which is 180 minus 120 because it's 60 degrees SAT and SATT. Now I mentioned earlier in a previous lesson how EATT is not one only way to get there. You can use SAT and SATT to find the value of Z. Either way, we're using some justification in order to prove why we're using why we get a certain value. Part D, another example. So we have this example, x plus y plus w, okay, and we have 30 degrees and 50 degrees here. And we need to determine z. So I can determine the value of x by determining SAT for this value, which is 130 degrees. I can determine x is equal to 180 minus 130 minus 30, which gives me SATT. That means that x is equal to 20 degrees. Next, what I need to do is to determine other values. So, other values, we would probably be given some more information about this triangle. For example, we would have figured out that W, okay, so what we have here is this triangle, and in this triangle we have SAT that we use to determine this particular angle, which is 130 degrees. Then we had to figure out X. To figure out X, we used SATT, and we took 180 minus the 130 minus the 30, and that gave us 20 degrees. Now, looking over here, we have an angle that's 60 degrees here. This is 30 degrees. And we should be able to figure out some other information on this particular graph. Note that these two sides are parallel, so we should be able to figure out, for example, what Z is. How many degrees will Z be? Well, Z will be, using the PLTC, we should be able to figure out what Z is. Z will equal 180 minus 60, and that will give us PLT. Using PLT, parallel line theorem C pattern, we should be able to figure out that Z is 120 degrees. Because Z is 120 degrees, we're also able to figure out what W is. W will be 60 degrees based on PLTC as well. So PLTC was used again to determine what W is, and therefore we can figure out what Y is by using SAT. Y will equal 180 minus 60 minus 20. And it turns out that our Y value will end up being 100 degrees. And that is using SAT. So now we have figured out all the letters X, W, X, Y, and Z. Okay, moving on to the next example. Next example, E. Given this diagram, we need to determine the value of A and B. To determine the value of A and B, we look at the information we're given. We know that this angle, for example, is 48 degrees. I know that this angle is 102 degrees. Can I figure out A? Well, yes, we can figure out A using, that's right, SAT. A equals 180 minus 102 degrees using SAT, which will give us 78 degrees. Now that I know what A is going to be 78 degrees, and this angle is 48 degrees, we can determine angle B. How do I know that this will equal angle B? Well, that's using OAT. So 180 minus 48 minus 78 using SATT and OAT will equal angle B. So SATT, the sum of the angles in the triangle theorem, plus OAT will give us angle B. Angle B will equal 54 degrees. Let's look at another example. Given these values, determine X, Y, and Z. So to determine X, Y, and Z, we need to use the parallel line theorem and another theorem called ITT for this part of this triangle. So to determine the value of X, we will use ITT and SATT to solve for X. So X is equal to 180 minus 50, all divided by 2 because we're using the isosceles triangle theorem, and SATT to determine the value. We figure out that X has to be 65 degrees. Because X is equal to 65 degrees, that tells me that Y must equal 65 degrees as well because of PLTF, or parallel line theorem F pattern. And finally, we need to figure out what Z is. Well, I know that this is equal, Y is equal to X. This angle is also equal to X because of PLTF, and therefore I can use SAT to figure out Z. Z is equal to 50 plus 65, which is another way to figure it out, which is using EATT. So whether you use PLTF and SAT, or you use EATT to determine that the sum of these angles is equal to Z, you will get the full marks. So it turns out that Z is equal to 115 degrees. All right, let's try for one more example. Example G, parallel line theorems, and we have a diagonal in there, and we have some algebra. How do we solve a question where we have algebra? Well, let's look at it logically. We know that these two angles must be equal to each other. They must be equal to each other because of the Z pattern. So let's use that information to determine the value of X. So 4X plus 50 equals 62 minus 2X because of PLTZ. Knowing that, we solve for x by saying 4x plus 2x is equal to 62 minus 50. That is, 4x plus 2x is 6x, and 62 minus 50 is 12. That means x is equal to 2. So we plug in a 2 here, and we plug in a 2 here, and we can figure out these angles. How does that help us? Well, specifically here, if we plug in the 2, this will be 54 degrees. 58 degrees. 58 degrees plus 45 degrees will help us figure out y. So, and that is, here we go. So this is how we're going to do the last part. Okay, the last part we figure out will be 62 minus 2 times 2 plus 45. So this piece plus y using PLTC will give us the value, will equal 180 degrees. So remember that C pattern says this angle plus this angle will equal 180. That's another way to solve this. And we do that when we solve for y by collecting all the like terms, moving things over, and we figure out that it's 180 minus 103, which the angle for y is going to be 77 degrees. So we have determined the value of x, we've determined the value of y, and we've answered the question. All right, folks, that's enough for the geometry lesson. Have a numerical day.